Hello everyone, my name is Meenakshi and this is the first lecture that I'll be doing as a part of the course on software testing that I'm currently offering for NPTEL. So what are we going to do today? Basically, I'll talk to you about the kinds of software that we encounter in the present world and what do expensive errors look like and how to avoid these expensive errors by using testing. So it's basically a motivation module where we deal with how important testing is. Right. So, what does software in the current century look like? If you look all around you, right, it's not too difficult to understand this software, right? So, we use Paytm, we use banks online, we go to an ATM machine, there's software. I make a call to my friend or my parents using my mobile phones, there's software, right? The software that controls the heating, ventilation, and air conditioning in our homes and offices. The software that tells you how electricity flows through our grids, how water flows through our networks, software that run in manufacturing industries, the software that help us to drive our cars better. There's autopilot and other kinds of software that help you to fly your planes well. There's software that controls the rail network. There's software even in toys that children use. Right? So what is our expectation about such a software? We all expect the software to be error free. Not only that, we want the software to respond fast, right? I insert my card into the ATM machine. I want the welcome screen the next second before I blink my eye. I can't wait long enough. And the other important thing to note is that if you consider a software like the autopilot of a plane, let's say there is an error in the software. You can't say that I'll shut it down mid flight, I'll rectify the bug, and I'll restart to be able to run, right? It's no longer feasible to be able to shut down a system because there's an error in the software. We want the system to be able to continue to run. In the autopilot case, it needs to be able to continue to fly the aircraft safely and help us to land safely. Right, so I'd like to talk to you about some popular errors that have occurred in the past. This first error is the error in a European Space Agency rocket called Ariane 5. It occurred exactly 21 years ago. And the important thing to note is that this error is because of a software bug. So there was this rocket called Ariane 5, which was being controlled by software that is launched by European Space Agency. So this software had the following error. So it was trying to squeeze in data corresponding to a 64-bit floating point number into a memory space that is allotted for a 16-bit integer. So obviously it's not going to be able to succeed in doing that. And because such rockets are safety critical systems, they always have backup software. But in this case, the problem was the backup software also had exactly the same error. So this resulted in transmission of incorrect altitude data to the aircraft, and this rocket Ariane 5 went and plunged into the Atlantic Ocean within 36 seconds after it was launched. So that's about 15 years of total effort, and you can imagine the millions of euros that would have been lost. So the next example that I'd like to discuss about is another unfortunate example that happened again because of a software error. So in this case, 6 patients lost their life due to a buggy software in a machine that gives radiation therapy to cancer patients. So there was a race condition error in this software. So this software ended up calculating more dosage of radiation than what was needed, and unfortunately, these patients lost their life because of an overdose of radiation. So, the next kind of example that I'd like to discuss with you is a software that is expensive, that costs somebody a lot. You all would have heard of these Intel Pentium processors, right? So, there was this particular P4 Pentium processor. A mathematician in the US, when he was trying to do research towards his prime numbers, he found that this Pentium 4 processor was doing floating point division wrongly. So when it was announced and Intel investigated, it realized that all the P4 processors that it had released into the market had the same error. So the only solution left was to be able to recall all these processes, and that cost Intel a lot of money. So this doesn't bring us to the end of expensive errors. If you Google, you can talk about, you can find Toyota brakes, crashes, all kinds of crashes happen. So here are some few reports that talk about how expensive errors can be and what is the cost of inadequate testing. National Institute of Standards and Technology in the year 2002 released a report which basically discussed the impact of software testing, in US. So it says that inadequate software testing causes the US economy anywhere between 22 and 59 billions every year, right? Not only that, the report goes ahead and says that if there are better approaches that can be found to do software testing, then you could bring down the amount of these losses to almost half of what it is. Right? The other popular categories of losses are due to web applications, which we use all the time, right? So, one particular thing that I'd like to discuss with you now happened almost 10 years ago. Amazon had this online discount sale, and because of a software error, what happened was that it ended up giving double the amount of discount. And by the time Amazon realized it, it was too late. It had already lost a lot of money, right? The next fact that I'd like to draw to your attention is a report that Symantec, the security organization, published in 2007. So it says that security related vulnerabilities that occur in our financial transactions, in our online wallets, and so on, mainly occur not because of cryptographic errors, they occur because of software errors. Right? So we know how expensive errors in software can be. So let's try to look at the various kinds of software and typically how they are developed. You might have heard of this buzzword called agile methodologies, right? So agile methodologies basically insist that people who develop the code, that is the developers, also have to unit test their code. Typically, developers don't have any great knowledge on testing, but agile methodology believes that a developer himself or herself is the best person to identify the error in the code. So that puts a lot of pressure on developers to be able to know testing well. Right now, let's look at the various kinds of software that we will deal with. Right, if you consider the software that typically runs in your cars that helps you to do braking automatically or does your cruise control, or a software that runs in your aeroplanes, such software is what is called embedded control software. So obviously such software runs in what are called safety critical systems where a failure can be catastrophic. So safety critical software have to meet regulatory standards by which regulatory authorities decide if a software has been tested enough and is fit for release. So this just means that almost double the effort goes into testing this software. Another popular kind of software is what is called enterprise software. So what would be a typical example of an enterprise software? Let's say a software that runs Citibank, right? Or a software that manages our Indian Railways ticketing system, right? What do such software have to deal with? They basically, the first complex thing is that they deal with fairly huge databases that have a lot of data, and the software is critically dependent on their server and backup server running all the time, right? The third popular category of software is what is called web applications, things like social networking sites, Amazon Online, and so on and so forth. We all know how important it is for these software to be correct. Finally, I'd like to end this slide with a point about free software. Suppose you pick up a piece of software from the internet for free, right? Just because it's available for free, you're not willing to accept the fact that the software could have errors, right? So paradoxically, we expect free software also to be error free. This is a very important slide. So this is a part of a study that was done at Carnegie Mellon University a few years ago. So this slide discusses about how expensive testing can get as we go down software development. So if you see a typical software development, initially you write requirements and then you do design, right? And then you unit test your software and then you put together the modules that you've tested and do what is called integration testing. Then you put the software along with the system or hardware that it's supposed to run on and you do system testing and finally release the software. So suppose there was an error in the requirements and it was found then and there, then what this slide tells you is that it gives you the cost. The cost is fairly low, right? But suppose there was an error that was found in requirements or design and it went all the way through testing, integration testing, system testing, didn't get detected at all. The software got released and the error was found then, right? Then what this slide tells you is that the cost of fixing that can be very, very high. It's not only the cost of fixing the error, the consequences of that error, as we saw through the examples, can also be really bad, right? So, what are the facts and myths about testing? There's a popular saying by Edgar Dijkstra who said that never think that you can use testing and say that I have proved my software to be correct. It's wrong to say that testing can prove a software to be correct. The main goal of testing is to be able to find errors in the software, right? Using testing, I can never say that I've tested my software and it's fully correct. It's a wrong statement to make. The other wrong statement to make is that a developer typically thinks that, I have written the code, I have debugged it well, and my quality auditor, my SQA in my company has inspected the code, so there's no need to test it. That typically will not work. It still needs to be tested. Another popular thought that people have, especially these people who sell software testing tools, is to be able to say that you just download and install my tool, it can do magic. It will do every kind of testing that you can think of. That's not true. The main goal of testing tools is to be able to help you execute the test cases and record the result. Now, to be able to design test cases, you have to be able to design test cases to find errors effectively. Typical Pareto principle applies here. 80% of the errors come in 20% of the code or design. So, test case design, which is what the course is about, needs a human to be able to do it. Right? So, I'd like to end this module by discussing about certain process maturity levels in testing. Why is it important to look at process maturity levels? It's important because it tells you what role testing plays in the software development that you do. Broadly, there are 5 levels, beginning from 0 and going all the way till 4. So, what does level 0 tell you? Level 0 tells you that there is basically nothing called testing. Developers write their code, they debug their code, they ensure that it's correct, and that's it. They go ahead and release it, right? So, it is clear that this doesn't really help to develop software that is considered to be fully safe and reliable. The next comes level 1 thinking. In level 1 thinking, a developer thinks that he or she has written a piece of code and their goal to test is to be able to show that the code is correct. As we saw a little while ago, I clearly cannot use testing to show that a piece of software is correct, right? So let's say a particular piece of code has an integer variable. To be able to exhaustively test it on a 32-bit processor, I need to be able to give every value, which is 2 power minus 32 to 2 power 32 plus or minus 1. And even on an extra fast PC, this is going to be able to take several years to do. So unless I test it for every value, I cannot say that the testing is correct. So here there is nothing like test engineers, and even if there are, they don't have goals and they just show that the software is not failed. But the underlying reason it's not failed because it's correct or it's not failed because you've designed the test cases wrongly, that's never clear. The next level is level 2 thinking, when you begin to believe that the goal of testing is to be able to identify failures or errors in the software. This is the beginning of positively using testing, but at organizations that are typically at this level, there's a lot of tiff between developers and testers. They belong to different teams, and then one doesn't want to help the other, and there is confusion, even though the goal of testing is fully realized. We move on to level 3, where they not only realize that the goal of testing is to find errors, but they also work together and say that we will not only find errors, we'll make sure that we reduce errors to the extent possible in the software, right? And there's also conscious understanding that when I release a software, there is a bit of risk involved. The risk could be high or the risk could be low, and my goal is to make the risk as low as possible. Level 4 thinking is where large organizations strive to be in. Here, testing becomes a mental discipline. So there is a positive thought and efforts in the organization level to make sure that testing teams' efforts are taken into consideration to develop software that is as error-free as possible, right? An organization like Microsoft will strive to achieve excellence in level 4 thinking, and this is what is the desired level that we would like to achieve in testing. Now, what has this course got to do with all the levels and terminologies that we saw till now? So this course will help you to think that I want to be able to do testing at levels 2, 3 or 4. So which means what? That the goal of my testing is to be able to find errors. So to find errors, I have to first define what are my testing objectives in technical terms, and I have to be able to figure out how to effectively design test cases to be able to meet or cover these test objectives. In the course, we will look at algorithms and techniques that will help you to formulate test objectives and design test cases that will help you to meet these objectives. So, the next module that we will be seeing, we will introduce the various terminologies that exist in testing and also clarify about what we would use as a part of this course. Thank you.